Okay, I hope I'm audible to all my students who are attending this particular lecture for the Advanced Mathematical Methods for Economics course. In this particular lecture, I'm going to start with the discussion of the 2023 question paper, which has come up at Delhi University for the Advanced Mathematical Methods for Economics, also called the MME3 course, for all those students who are pursuing economics honors from University of Delhi and are in the second year. Now, in this particular lecture, I'm going to start with the discussion of problems from section A. So first of all, I hope all students can see section A on your screens. Okay, if you look at the format of section A, there are 6 questions in section A, out of which we need to only attempt 4. But I will be solving all problems from this particular section. Okay, so in this particular lecture, I'm going to start with the discussion of problem 1. Okay, so let's quickly start with this particular lecture. Question 1, as all students can see, further has 2 parts, part A and part B. Let's first of all look at part A. Let the rate of growth of output be given by the function. So students, this is also, there are some typos in this paper. I will be making the corrections in the paper itself. This is Q dot T. This is Q dot T. The rate of growth of output is given by the function Q dot T, which is 12t to the power 1/3. Okay, so this is what we are given. And if Q of 0 is 20, find the time path of output level. So I need to find Q of T. This is what I need to find. We are given Q dot T, which is the rate of growth of output with respect to time. Okay, and we are given the initial value of output at time period t equal to 0, which is 20. So Q of 0 is 20. We need to find the time path of the output level. So remember, it's a question based on integration, which I have covered up in my lectures on the Advanced Mathematical Methods for Economics course. If I integrate Q dot T, I get Q of T. And the question also asks us to find the total production during the initial 3 years. So let me quickly come to the whiteboard first to solve this particular problem. I'm writing the main heading for completeness. We are looking at the Delhi University 2023 question paper for the Advanced Mathematical Methods for Economics, which I also call as the MME3 course. And this is for all those students who are pursuing economics honors from University of Delhi. So question 1, part A, I'm quickly writing what is given to us. We are given that the rate of growth of output is given by Q dot T equals 12t to the power 1/3. We are also given that the initial value at time period 0 for this output is 20. Okay, and I need to find Q of T, which means I need to find the production of output level at time t. So this is going to be, how do I find Q of T? I'm going to integrate. What am I going to integrate? I'm going to integrate Q dot T with respect to T. Remember, when I integrate the derivative, I get back the main function itself. So integral is the antiderivative. Integral is also called the antiderivative. Remember? So when I integrate the rate of growth of output, I get back the production function. Okay, so this is going to be integral. Q dot T is 12t to the power 1/3 dt. We know how to integrate this. Students should watch my lectures on integration before watching this particular lecture. This is going to be 12 times integral t to the power 1/3 dt. How do I find the integral of t to the power 1/3? It's t to the power 1/3 plus 1 over 1/3 plus 1. Okay. plus the constant of integration I get. Now the constant of integration will be nothing but the production of output at time period 0. Okay, the constant of integration, this is nothing but C, which is my constant of integration. Remember, the constant of integration is nothing but the value of output at t equal to 0. Okay, so if I further solve this, I can write therefore q of t is going to be 12 times t to the power 4 by 3 over 4 by 3 plus q of 0 is how much? Q of 0 is 20. So this implies q of t is going to be, it's going to be 9. 12 divided by 4 by 3. If I do this in rough, it's going to be 12 times 3 over 4. 4 cancels with 12, making it 3. 3 times 3 is 9. So this is 9 t to the power 4 by 3 plus 20. Okay, this is my q of t. This is my answer for q of t. That means the value of production at time period t. And now what else is the question asking us? Coming back to the question paper. Also find the total production during the initial 3 years. That means I need to find what's the total production from year 0 to year 3. So if I erase all this off, erasing all this off, I can write that Q of T in the initial 3 years will be, it is going to be, so I cannot write Q of T, instead I can write total production. Total production during the initial 3 years. Total production during the initial 3 years is gonna be integral from 0 to 3. What do I integrate? Qt dt. So integral from 0 to 3. What is Qt? We just found that Q of t is 9 t to the power 4 third plus 20. And I'm going to integrate this with respect to t. Let me correct myself. I'm going to integrate q dot t because that is my rate of growth of output. So the total production during the initial 3 years will be integral 0 to 3 q dot t dt. Q dot t is 12 t to the power 1 third dt. Remember guys, I'm repeating one thing again for clarity. When you integrate the rate of growth of output, you get back the total production. So when I integrate q dot t with respect to t, I get total production, and I need to find total production during the first 3 years. That means from year 0 to year 3. Okay, so q dot t is 12 t to the power 1 third. So this is going to be 12 times t to the power 1 third integral 0 to 3 t to the power 1 third dt. Now this is definite integrals. Okay, what do I get when I integrate t to the power 1 third? So I get this only. When I integrate it, I erase this part off at the bottom. So I get 12 times t to the power 1 third integral is t to the power 1 third plus 1 over 1 third plus 1 plus the initial output level at time period 0 was 20. So this is, and I run this from 0 to 3. I run this from 0 to 3. Okay. So run this from 0 to 3. So this is going to be 12 times 9 t to the power 4 by 3 plus 20, which I run from 0 to 3. So what do I get my answer? First put 3 in the expression, then minus put 0 in the expression. So this 12 is going to vanish, students. We are only left with 9 times t to the power 4 by 3 plus 20. So let me revise it again. Total production during the initial 3 years will be, I integrate from 0 to 3. What do I integrate? Q dot t dt. When we integrate q dot t dt, we get q of t. And q of t is the total production at time t. I need to find total production during the initial 3 years. That means as t goes from 0 to 3, I integrate q dot t dt. Q dot t dt is 12t to the power 1/3. 12 comes out because constants come out of the integral. I integrate t to the power 1/3. T to the power 1/3 integral is t to the power 1/3 plus 1 over 1/3 plus 1 plus q to the power 0. I'm revising it here again with all students. Integral of x to the power n with respect to x is going to be x to the power n plus 1 over n plus 1 plus the constant of integration. This is what all students should recall from my lectures on integration. So this expression comes out as t to the power 4 by 3 over 4 by 3. This 4 by 3 cancels with 12, making it 9. Just as we had done a few minutes back, times 9 t to the power 4/3 plus q of 0 is 20. I run this from 0 to 3. So now I'm going to solve this further. So if I erase all this off, I can write that total production during the initial 3 years. Total production during the initial 3 years is going to be, first put t as 3, so 9 times 3 to the power 4/3 plus 20 minus, now put t as 0, so 9 times 0 to the power 4/3 plus 20. So when I solve this, what do I get? So this is 9 times 3 to the power 4/3 plus 20 minus, this is 0, minus into plus is minus 20. Okay, so what do I get? This is 20 and minus 20 cancel out. My answer is 9 times 3 to the power 4. This is my answer for the total production during the initial 3 years. Okay, so I'm revising it. When we integrate, remember students, when we integrate q dot t with respect to t, we get q of t. And the total production during the initial 3 years will be integrating from 0 to 3 q dot t. So with this, we are done with question number 1, part A. Let's look at question number 1, part B. So coming back to the question paper. Find the area of the region between the curves y1 equals 3x square minus 6x plus 3, y2 equals minus 2x square plus 1 within the interval 0 to 2. So if you look at these two functions, they are parabolas. We have done this in the introductory mathematical methods for economics or the MME 1 course. When y is quadratic in x, it's a parabola. It's a parabola with the vertical axis. Okay, so let me quickly come to the whiteboard and let's quickly solve this particular problem. So question 1, part B, we are given y1 is equal to 3x square minus 6x plus 3. Y2 is equal to minus 2x square plus 1. And I need to find the area. I need to find the area of region. Area of the region between the above two curves within the interval 0 to 2. Again, this is an application of integration. This is all based on definite integrals, which I have covered in quite depth in my lectures on integration. Okay, so let's first of all see how these two functions look like. So consider y1 is equal to 3x square minus 6x plus 3. Okay, you can clearly see that since y1 is quadratic in x, hence it is a parabola. Hence it is a parabola with vertical axis. Students should recall this from my MME1. Recall from my MME1, or I can say Introductory Mathematical Methods for Economics course, which students have done in semester 1 of BA Honors Economics. Okay, so if I just convert to the standard form of parabola, so I can write y1 is equal to, I can take 3 common. So inside I get x square minus 2x plus 1. So this implies y1 is equal to 3 times. I can split the middle term, x square minus x plus 1, which implies y1 is equal to 3 times x. I'm factorizing it now. X into x minus 1 times x minus 1, which implies y1 is equal to 3 times x minus 1 square. And if I compare it with the standard form, x minus h square is equal to 4 alpha times y minus k. This is the standard form of the parabola. So this I can write as x minus 1 square is equal to 1/3 times y1 minus 0. So comparing star and star dash, this is equation star, this is star dash. Comparing star and star dash, the vertex of the parabola is h comma k. We all know this from the MME1 course. H is 1 and k is 0. And alpha, so 4 alpha is 1/3. 4 alpha is 1/3, which implies alpha is 1/12, which is positive. Alpha is positive means the parabola is opening upwards. So I can say this is a parabola with vertex at 1, 0 and opening upwards. That means it's U-shaped. Now let's look at this particular parabola. So if I erase all this off, erasing all this off, again I can write, consider y2 is equal to minus 2x square plus 1. Again, since y2 is quadratic in x, since y2 is quadratic in x, hence it is a parabola with vertical axis. Okay, again, recall this from my MME1 course. Now again, what's the general form? X minus h square is equal to 4 alpha times y minus k. So can I try and convert this to this form? Okay, I can do that. So y2 is equal to minus 2x square plus 1, which implies y2 minus 1 is equal to minus 2x square, which implies minus half. I can take minus 2 to this side, becomes minus half times y2 minus 1 is equal to x square. I can write as x minus 0 square. Okay, so comparing 1 and 2. Comparing 1 and 2, I have h comma, my vertex is what, guys? If I write this clearly here, the vertex is h comma k, which is h is 0, k is 1. Vertex is 0 comma 1, and 4 alpha is minus half, which implies alpha is minus 1/8, which is negative. So I can say that this parabola is opening downwards. It's opening downwards. So I can write here that this is the parabola with vertex at 0, 1 and opening downwards. If I erase all this off, opening downwards. Opening downwards, I can write inverted U shape. Inverted U shape. Now, what do we need to do? Let me write this clearly so that all students can copy this properly. Inverted U shape. Now, what do I need to find? Remember, I'm writing it again. I need to ultimately find the region between the two curves. Region between the two curves within the interval 0 to 2. So I need to first of all plot them. So if I erase all this off, I can plot them. Let's quickly plot them, students. Let's look at a rough sketch or a rough diagram for this. This is X, this is Y. Okay, look at the first parabola in black color. Vertex is at 1, 0. So this is 1. This is 1, 0. Okay, and it's opening upwards. That means it somewhat looks like this. If I plot it, somewhat looks like this. This is Y1, and in red color, vertex is at 0, 1. So let's say this is 1. Okay, so let me also, since we are drawing a rough sketch, we need to be like somewhat accurate, not exactly accurate. So let me also, find this point for all students. What will this point be? So when X is 0, what will Y1 be? When X is 0, Y1 is 3. So that means, let me somewhat draw a more accurate graph. So this is 3. When I put X as 0 in this, I get Y1 as 3. So my graph is going to somewhat look like this. This is Y1. And the red one is the graph for Y2. Vertex is at 0, 1. So this is 1. And it's going to be inverted U shape from here. Let me draw it more properly. Remember, I'm not using any scale of measurement. So might come out a bit asymmetric. So this is 1, 0. Okay, so somewhat like this is going to be my Y. I need to find the area between the curves from 0 to 2. That means somewhat this area is what I need to find out. As X takes values from 0 to 2. Okay, so how do I do that? So area between the curves is given by area between the curves is I need to find the area in the interval 0 to 2. That means as X takes values from 0 to 2. So area of Y1, which is 3x square minus 6x plus 3. Okay, minus the equation of Y2. Equation of Y2 is minus 2x square plus 1. And I integrate this with respect to which variable? With respect to the variable X. So area between the two curves is area below Y1 minus area below Y2. Okay, so this is the area under Y1 minus this is the area under Y2. So I'm erasing the diagram. It was just given to help students visualize as to what exactly we need to find out. So it's area under the y1 curve minus area under the y2 curve, which gives you the area between the y1 and y2. This is going to be integral. If I write this clearly, it's going to be integral from 0 to 2. Let me find this whole. So this is going to be 3x square minus 6x plus 3 minus into minus makes it plus 2x square. And then again, I have minus into plus 1 is minus 1 dx. This is going to be integral 0 to 2. 3x square plus 2x square is 5x square minus 6x plus 3 minus 1 is 2. Okay, integral of 5x square is 5x cube by 3. Integral of 6x is 6x square by 2. Integral of 2 is 2x. I run this from 0 to 2. This is going to be 5 into 2 cube by 3 minus 6 by 2 times 2 square plus 2 into 2. And guys, when I put 0, this will be 0, this will be 0, this will be 0. So the whole thing is minus, subtracted 0. So if I erase all this off, I get 5 by 3 times 2 cube is 8 minus 6 by 2 times 2 square is 4 minus 4. So 2 cancels with 6, making it 3. So I have 40 by 3 minus 12 minus 4, which is 40 by 3 minus 16. Comes out as how much? This comes out as, this is plus 4, guys. This is plus 4. Please make this correction. This is plus 2 into 2, which is plus 4. I think I made a mistake. I'm correcting it now. Okay. When you put x as 2, this is plus 2 into 2. So plus 4, that means plus 4. So minus 12 plus 4 is going to be now a correction here. It's going to be as follows. 40 by 3 minus 8, which is going to be 40 minus 24 by 3. My answer is 16 by 3 square units. This is my answer for the area between the two. 16 by 3 square units is the area between the two curves y1 and y2. So all I had to do was just draw a rough sketch, just get a rough idea of the graph, and just integrate from 0 to 2 area below y1 minus area below y2. And just perform the normal integration. So hoping all students have understood how we have solved this. So students, this is where I stop in this particular lecture. If I come back to the question paper, we have done question 1 completely in this lecture. Okay. In the next lecture, I'm going to look at question number 2. So this is question number 2. I intend to solve this in the next lecture. So I stop in this lecture. I hope students have enjoyed this lecture. Any doubts? You can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can always mail me your doubts at divineschoolofelconomics@gmail.com. This is where I stop in this lecture.